In question 3, we are given a bunch of word problems. For each problem, we have to set up a pair of linear equations and find their solution using the substitution method. So let's do that for each of the 6 parts one by one. Also, in each case, what we will do is verify whether the solution we obtain satisfies the original constraints given in the problem. Okay, so let's start with the first problem. So the first problem says that the difference between two numbers is 26 and one number is 3 times the other. Find these numbers. So we start by supposing that the first number is x and the second number is y. And now what we have to do is we have to set up a pair of linear equations in these two variables x and y. Now the problem says that the difference between these two numbers is 26. So if we assume that the first number is larger than the second number, then the difference, which is x minus y, this is equal to 26. Also, the statement says that one number is 3 times the other. So the larger number x is 3 times the smaller number y. Now we have a pair of linear equations in x and y, and all we need to do is solve this pair using substitution and find the values of x and y. So from the second equation, I have x equal to 3y. So let me substitute this into the first equation. So the first equation is x minus y equal to 26. So instead of this x, I write 3y. So this is the substitution that I do. So 3y minus y is equal to 26, which means that 2y is equal to 26 or y is equal to 13. So we get y equal to 13, and then from this second equation we have x equal to 3y, which means that x is equal to 3 times 13 or 39. So the two numbers are, the first number is 39 and the second number is 13, and we can verify that their difference, 39 minus 13, this is equal to 26, and 39 is 3 times 13. So both the constraints in the given problem are satisfied, and hence the answer is the two numbers are 39 and 13. Okay, so the second part says that the larger of two supplementary angles exceeds the smaller by 18 degrees. Find the two angles. So the two unknowns in this problem are the two angles. So let's assume them to be some variables. So let's say that the larger angle, let's assume that the larger angle is x degrees, and let's assume that the smaller angle is y degrees. Now the given problem statement actually gives us two pieces of information about x and y. The first thing it says is that the two angles are supplementary, which means that their sum should be 180 degrees. And from this we can write our first equation, x plus y should be equal to 180. The second thing that this problem statement tells us is that the larger of these angles exceeds the smaller by 18 degrees, which means I can write x is equal to y plus 18, because the larger angle exceeds the smaller or is larger than the smaller by 18 degrees. So these are the two equations that model the given situation. And now what we have to do is we have to solve this pair and find the values of x and y, and we will do this using substitution. So the second equation gives us x in terms of y. So x is equal to y plus 18. So let's substitute this value of x into the first equation. So the first equation is x plus y equal to 180. Instead of x, let's write y plus 18. So this is x plus y is equal to 180. So this is an equation in y alone, and now let's solve it to find the value of y. So we have 2y plus 18 is equal to 180, which means that 2y is equal to 180 minus 18 or 162, and this means that y is equal to 162 by 2, which is equal to 81. So y is equal to 81, and now we can use this second equation to find x from y. So x is equal to y plus 18. So x should be equal to 81 plus 18, which is equal to 99. So we have obtained the values of x and y, and hence we can say that the answer is that the larger angle, which is x degree, this is equal to 99 degree, and the smaller angle, which is y degree, is equal to 81 degree. And that's our answer. And we can verify that 99 degree plus 81 degree is equal to 180 degree. So these two angles are supplementary, and 99 degree is 81 degree plus 18 degree. So the larger angle exceeds the smaller angle by 18 degree. The third problem in this question says, the coach of a cricket team buys 7 bats and 6 balls for 3,800 rupees. Later, she buys 3 bats and 5 balls for 1,750 rupees. Find the cost of each bat and each ball. So the two unknowns in this situation are the cost of each bat and the cost of each ball. So let's assume some variables for these two unknowns. So let's say that the cost of each bat, or the cost per bat, this is equal to rupees x, and let's assume that the cost per ball, or the cost of each ball, this is equal to rupees y. Now we have to use the given pieces of information to set up a pair of linear equations in x and y. Now the first piece of information says 7 bats and 6 balls for 3,800 rupees. So the total cost of 7 bats and 6 balls should be 3,800 rupees. Now 7 bats will cost 7x rupees because the cost per bat is x rupees, and 6 balls will cost 6y rupees because the cost per ball is y rupees, and their total should be equal to 3,800. So this is the first equation that we get. And now the second piece of information we have is 3 bats and 5 balls for 1,750 rupees. So 3 bats will cost 3x rupees, 5 balls will cost 5y rupees, and their total should be equal to 1,750. So this is the second equation in x and y. So now we have obtained a pair of linear equations in x and y. What we have to do now is we have to use substitution to solve for x and y. So if I take the first equation, what I can do is I can write y in terms of x using the first equation. So the first equation is 7x plus 6y equal to 3,800. From this I can write 6y equal to 3,800 minus 7x, or y is equal to 3,800 minus 7x by 6. So from the first equation I can write y in terms of x like this. And now what I'll do is, in the second equation, instead of y, I will substitute this expression in x. So let's do that. So what we'll get from the second equation is 3x plus 5y, and instead of y, I will write this expression in x, which is 3,800 minus 7x by 6, and this should be equal to 1,750. Now this equation that we get is an equation in x alone. So let's solve it to find the value of x. So we have 3x here and we have the 6 here. So let's take the LCM of the two terms on the LHS. So I will get 3x will become 18x, and I will get 5 times 3,800, so that's 19,000, and then 5 times minus 7x, so that's minus 35x, and then I will have a 6 below all these terms, and this 6 I can take to the right side and multiply it on the right side, and I will get 10,500 on the right side. So from here I get 18x minus 35x, so that's minus 17x, and I can take this 19,000 to the right side, subtract it from 10,500, and this will give me minus 8,500. So this means that x is equal to minus 8,500 by minus 17, which is equal to 500. So x is equal to 500. And now I can use this expression for y in terms of x to find the value of y. So y should be equal to 3,800 minus 7x. So because x is 500, 7x is equal to 3,500. So I have minus 3,500 by 6. So 3,800 minus 3,500 is 300, and 300 by 6 is 50. So y is equal to 50. So we have managed to solve the pair of linear equations. We get x equal to 500, we get y is equal to 50. So the cost per bat is rupees 500 and the cost per ball is rupees 50. And now we can verify whether our values are correct. 7 bats and 6 balls should cost 3,800. So 7 bats will cost 3,500 and 6 balls will cost 300. And the total is 3,800. So the first piece of information gets validated. And then we have 3 bats which will cost 1,500 and 5 balls which will cost 250. So 1,500 plus 250 is 1,750. So we also find agreement with the second piece of information. So the final answer is that the cost per bat is rupees 500 and the cost per ball is rupees 50. Part 4 in this question says, the taxi charges in a city consist of a fixed charge together with the charge for the distance covered. So the fixed charge is like a down payment, and then there's a charge for the distance covered. For a distance of 10 kilometers, the charge paid is rupees 105, and for a journey of 15 kilometers, the charge paid is rupees 155. Now the question asks us, what are the fixed charges and the charge per kilometer? And then how much does a person have to pay for traveling a distance of 25 kilometers? So the two unknowns in this problem clearly are the fixed charge and the charge per kilometer. So let's say that the fixed charge is rupees F. So F is for fixed. So rupees F is the fixed charge or the down payment, and then let's assume that the charge per kilometer is rupees C, the charge per kilometer. Now we have to form, using the given information, we have to form a pair of linear equations in these two unknowns F and C, and then we have to solve them and find the value of F and C. So what are the two pieces of information given to us that will help us set up two linear equations? Well, the first one is, for a distance of 10 kilometers, the charge paid is rupees 105. So the fixed fare will be F, and the per kilometer rate for 10 kilometers, this will translate to a cost of 10C. So for a journey of 10 kilometers, for a distance of 10 kilometers, the total charge will be F plus 10C, the fixed charge plus the charge for the distance traveled, and this is equal to 105. So this is the first equation that we get in F and C. And then the second piece of information is, for a distance of 15 kilometers, for a journey of 15 kilometers, the charge paid is 155. So for this journey, the fixed charge will be F, and the charge for the distance traveled will be 15C. So the total cost in this case will be F plus 15C, and this is equal to 155. So these two equations are the pair of linear equations that model the given situation in this case, and now we have to solve them using substitution, and we have to find the value of F and C. So what we can do is take one of the equations and write one of the variables in terms of the other. So I will take the first equation and I will write F in terms of C. So we have F plus 10C is equal to 105. So from here I can write F is equal to 105 minus 10c. And this expression for f I will substitute into the second equation. So the second equation is f. So instead of f I will write 105 minus 10c, and then we have this plus 15c is equal to 155. So now this is an equation in c alone. So let's solve it and find the value of c. So we have 105 minus 10c plus 15c, so this is equal to plus 5c, and this is equal to 155. So now I can isolate 5c on the left side, take this 105 to the right side, subtract it from 155 to get 50 on the RHS. So 5c is equal to 50, which means that c is equal to 10. And from c equal to 10, I can now find the value of f. So f will be equal to 105 minus 10c, or 10 into 10. So this is 105 minus 100, which is equal to 5. So f is equal to 5 and c is equal to 10. The fixed charge is equal to rupees 5 and the charge per kilometer is equal to rupees 10. So let's quickly verify whether these values are correct. So for a distance of 10 kilometers, the total cost will be 5, the fixed charge, plus 10 times 10. So that's 5 plus 100, or 105. So this aligns with the first piece of information. And then for a journey of 15 kilometers, the fixed charge will be 5 and the charge for the distance will be 15 times 10. So that's 150. So 5 plus 150 will be equal to 155. So this aligns with the second piece of information. So these two values are correct. And now the last part of the question is, how much does a person have to pay for traveling a distance of 25 kilometers? So the total cost, let's call it x. So the total cost for this journey of 25 kilometers will be the fixed cost, which is the fixed charge, which is rupees 5, and then the cost for 25 kilometers traveled, that will be 25 times 10, the charge per kilometer. So 5 plus 250, so that's 255, or rupees 255. So the person will have to pay rupees 255 for traveling a distance of 25 kilometers. The fifth part of this question says a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. And if 3 is added to both the numerator and the denominator, it becomes 5 by 6 instead. Find this fraction. So clearly the fraction is the unknown, and actually there are two unknowns. The numerator and the denominator are both unknowns. So let's assume that the numerator is equal to x, some integer x, and the denominator is equal to some integer y. So which means that the original fraction is x by y. Now if 2 is added to both the numerator and the denominator, what do we get? So the first piece of information tells us that the fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. So the numerator becomes x plus 2 and the denominator becomes y plus 2, and this changes the fraction into 9 by 11. So this relation gives us our first equation in x and y. I can write it in the standard linear equation form by cross multiplying. So I multiply 11 with x plus 2 and I multiply 9 with y plus 2. So this gives me 11x plus 22 is equal to 9y plus 18, and I can write this as 11x plus or minus 9y plus 4 equal to 0. So this is the first equation in x and y. And now let's use the second piece of information. If 3 is added to both the numerator and the denominator of the original fraction, it becomes 5 by 6. So if I add 3 to the numerator and 3 to the denominator, the new fraction is x plus 3 by y plus 3, and this numerical value of this fraction is 5 by 6. So again, from this we can find out our second linear equation in x and y. So let's multiply 6 with x plus 3 and 5 with y plus 3. So this will give me 6x plus 18 is equal to 5y plus 15, and I can write this as 6x minus 5y plus 3 equal to 0. So the two equations that we get in this situation are 11x minus 9y plus 4 equal to 0 and 6x minus 5y plus 3 equal to 0. Now what we have to do is we have to solve this pair of equations by substitution and find the values of x and y. So let's do that now. So what I will do is, from this second equation I will write y in terms of x, and then I will substitute that into the first equation. So from the second equation I have 5y is equal to 6x plus 3, or y is equal to 6x plus 3 by 5. So this value of y, I will now substitute it into the first equation. So let's see what we get. So we have 11x minus 9y. So 9y, but instead of y, let me write 6x plus 3 by 5. And this is, and then we have a plus 4. So plus 4 is equal to 0. Now this is an equation in x alone. So let's solve it and find the value of x. So we have this 5 here. So let's take an LCM of 5 across all the terms. So 11x becomes 55x. And then we have minus 9 times this 6x plus 3. So that's minus 54x minus 27. And then we have this 4 which turns into a 20 because of the LCM of 5. So this is equal to 0. I've also multiplied 5 on the right side and the RHS becomes 0. So this is what I get. So 55x minus 54x is x, and x minus 27 plus 20 or minus 7 is equal to 0, which means that x is equal to 7. And if x is equal to 7, then y is equal to, I can find it from this expression, 6x plus 3 by 5. So y is equal to 6x. 6x is 42. So 42 plus 3 by 5, or 45 by 5, or 9. So the numerator, the original numerator is 7 and the original denominator is 9, which means that the original fraction is 7 by 9. And now let's see if this answer aligns with the information given to us in the problem. So I have the original fraction as 7 by 9. If I add 2 to both the numerator and the denominator, I get 9 by 11, which aligns with the first piece of information given to us. And if I add 3 to both the numerator and the denominator, I get 10 by 12, and 10 by 12 in lowest form is 5 by 6. And this aligns with the second piece of information given to us. So our answer is correct. The original fraction is 7 by 9. The sixth and the last part of this question says 5 years hence. Hence means later. So 5 years later, the age of Jacob will be 3 times that of his son. And 5 years ago, which means 5 years in the past, Jacob's age was 7 times that of his son. What are their present ages? So the two unknowns in this problem are clearly the age of Jacob and the age of his son. So let's assume that Jacob's age is x years. Jacob's age is x years, and let's assume that his son's age is y years. So the two unknowns in this situation are x and y, and using the given information we have to set up a pair of linear equations in x and y. Now the first piece of information says 5 years hence the age of Jacob will be 3 times that of his son. So 5 years hence, or 5 years from now, or 5 years later, Jacob's age will be x plus 5 and his son's age will be y plus 5, and the statement says that Jacob's age will be 3 times that of his son's age. So x plus y should be equal to 3 times y plus 5. And this gives us our first linear equation in x and y. So let's write it in the standard form. So we have x plus 5 is equal to 3y plus 15. And let me write this as x equal to 3y plus 10. So basically I've taken this 5 on the right side and subtracted it from 15. So this is the first equation in x and y. Now the second piece of information is that 5 years ago Jacob's age was 7 times that of his son. So 5 years ago Jacob's age would have been x minus 5 and his son's age would have been y minus 5, and Jacob's age was 7 times his son's age. So x minus 5 should be equal to 7 times y minus 5. So this gives us our second equation in x and y. Let's write it in the standard form. So we have x minus 5 is equal to 7y minus 35, or x is equal to 7y minus 30. So I've taken this 5 and added it on the right side. So the two equations we get are, let's write them here, x equal to 3y plus 10 and x equal to 7y minus 30. So these are the two equations we get. Now we can solve them using substitution and find the values of x and y. So from the first equation, x is equal to 3y plus 10. So let me substitute this into the second equation. So from the second equation I get x, or 3y plus 10, is equal to 7y minus 30. So I can take this 3y on the right side and that becomes 7y minus 3y, or 4y, and this minus 30 on this side with 10, so that becomes 40. So 4y is equal to 40, or y is equal to 40 by 4, or 10. So y is 10, and then from any of these two equations we can find the value of x. So let's use the first equation. So x is equal to 3y plus 10, or 30 plus 10, or 40. So x is equal to 40 and y is equal to 10. So Jacob's present age is 40 years and his son's present age is 10 years. Now let's verify quickly whether this aligns with what's given to us. So 5 years later Jacob's age will be 45 years and his son's age will be 15 years. So Jacob's age will be 3 times his son's age. So that aligns with the first piece of information. And then 5 years ago Jacob's age was 35 years and his son's age was 5 years, and 35 is 7 times 5. So Jacob's age was 7 times that of his son. So that aligns with the second piece of information given to us. So these answers 40 years and 10 years are correct for the ages of Jacob and his son. And this finishes this question of this exercise. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.